Hello and welcome to Moving the Cobot Welder into Traditional Automation with Synchronous Motion. Attendees of this webinar session will learn how fabricators can leverage the power of our newest Motion Plus release for synchronized and coordinated motion, engage with a true expert in welding automation, and hear stories of how others have already leveraged the power of external access for boosting welding productivity, and learn how cobots are helping to transform manual and traditional welding. My name is Jules Romeo, and I'll be your host for this webinar. Thank you for joining us today to hear from Will Healy III, Global Industry Manager for Welding at Universal Robots, and Matt Hendy, Founder and CEO of THG Automation. If you have questions for the presenters, please type them in the box on the upper right side of your screen, and we will address as many of them as possible after the presentation. If you have any audio or visual issues, please refresh your page by using the F5 key or try a different internet browser. A reminder that Chrome is preferred. Now I'll pass it on to Will Healy.
Perfect. Thanks, Jules. Hopefully you can hear me and everything's good. So I'm really excited to have you all here today. I'm even more excited to have with me Matt Hendy from THG Automation. And so we're going to dive right in and share with you a lot of really hopeful, interesting, and useful information today. You know, I always like to start out with, in metal fabrication, we do have some challenges, right? And we're going to talk about today how collaborative robotics is helping this. But those challenges are things like major market trends that are having an impact, like our aging workforce and our rising labor costs. We have persistent vacancies. Even with the softening in the market, we still have nearly 900,000 job openings as of half a year in the United States in manufacturing and warehousing and logistics. Then, you know, we've got skilled labor immigration if you're in low cost of labor areas. And then there's just general economic headwinds going on right now that are all having an impact. You know, also traditional automation requires robot technicians. And these robot technicians, you know, their mechatronic skills and electrical and automation skills, these are in short supply. So when we have limited staff, it's really hard to take somebody and send them to a 2-week offsite training course. So that really, or if that person leaves and goes fishing, no one can run the robot because Jim's the only one that knows how to run it and he's off fishing. So what I want you to think about is don't try to trade one hard to fill role like a welder with another hard to fill role like a robot tech. So, you know, one of the hugest things that Cobots really bring, one of the biggest things Cobots really bring is the people you have today can do collaborative robotics. And then when we look at the weld shop itself, there can be a challenge, right? Depending on the material coming in, we can get unpredictable part fit up, or we can get variable worker productivity. On a hot day, we make less parts. On a cold day, we make less parts. On a day after the Super Bowl, we make less parts. You know, so there's really that variable productivity. There's post-process grinding and pre-assembly of parts or banging it with a hammer. And so we get kind of this inconsistent productivity. We end up with inconsistent output quality. If we're taking someone from a fryer on Friday and handing them a weld torch on Monday, it can cause quality issues. And really, ultimately, all that puts together really erratic production planning for the production management. And how do we get more consistency and more predictability in the weld shop itself? All these things come together and many more challenges that we're facing. You know, it delays our production schedules. We have that inconsistent product quality. We could even lose customers or lose opportunities, even turn away business sometimes. We've talked about in other webinars. And so how, you know, all this impacts your competitiveness, and it maybe even raises the churn of welders you have, ultimately leading to a lower profitability and productivity. So if we want to overcome those, collaborative welding is one way that many metal fabricators are overcoming this. So what is collaborative welding? And I want to talk about that with you today real briefly. You know, we have always embraced new tools and work. When we look at assemblers aren't using a basic screwdriver anymore to screw drive things and assemble things together. They're using drills and torque guns, right? It's raising the quality level. It's making the work easier for the worker. When we look at carpenters out in the field, they have a nail gun. They're not banging things with hammers over and over again all day. They get less repetitive stress injuries, and it's That's better quality, more consistent assembly of the carpentry. So when we look at other professions, especially other skilled trades, we see that there's investments in tools to make the work better. And the collaborative robot is really one of those tools. We need the knowledge of the welder to build the weld. We need the knowledge of the welder to teach the robot what to do. But this is a new tool that we should embrace, just like the torque gun is there for an assembler, and just like the nail gun is there for a carpenter. So we look at the Universal Robots Cobot, and what's really powerful there is it's a very user-friendly technology for welders. The programming interface is very simple with step-by-step pictures from different partners, simple to set up, and you can review the path before you weld to make sure that you're getting the right angles and the right path you want. And then the ability to reach out and grab the robot and put it where you want it, be able to free drive for positioning the torch. Welders are very mechanical. Welders grab the torch and physically put the torch where they need it. They can grab the robot and put the robot where they need it. And so it's very easy for a welder to understand how to interface with the software. And then ultimately, the collaborative welding tools utilize this kind of easy and intuitive touch to teach style of programming that basically eliminates the need to be a robot programmer. And so, partners like THG, and you're going to see some of their stuff today, they've got a teach flange on the end of the robot. So you can bring it in and free drive, and you can program in simple buttons. This allows us to do changeovers quickly. This allows us to really teach people quickly how to utilize a collaborative robot. So the power of this is really coming for folks in that we're not replacing the welder. We're really augmenting them and making them more efficient. Better quality is coming out, more consistent quality is coming out over long batches and long runs. And then the welder's more engaged because instead of doing boring work now, they teach the robot to do a simple 6-inch straight line weld. The robot does the 1,000 pieces while the welder goes and does something more creative. And so it gets rid of that focus on robot programming and gets people welding. So Universal Robots and our partners have been doing collaborative welding for almost 8 years. The initial welding applications mostly were in the MIG space with a little bit of TIG, some TIG actually, and more than a little bit. And there are a lot of skill capabilities inside the partners, weaving and patterns and tacking and all these kinds of things, multi-pass and different layers and circular arcs and linear paths, and many different power sources are compatible. And you're going to hear from Matt about Fronius specifically today. But ultimately, this first wave of collaborative welding capabilities brought value in 3 ways. And the 3 ways are: it expanded the manual welder productivity. Most of the case stories you hear, 2x, 4x, even 10x sometimes, raising that arc time per shift, giving more time for cutting or part preparation, giving them, helping them accelerate the startup of a new part or changeovers being faster. It also drives production quality and consistency. It improves the process repeatability, so we're making the same part each time, reduces the rework queue because we're not over welding and we're not creating parts of the part. We're not creating areas of the part that we have to rework. And we're eliminating distracted welding from dull, repetitive volumes. If someone has to make 1,000 hanger brackets, that can be really boring. And we can probably see exactly where that welder gets bored. And then it increases that welder engagement and retention because we're reducing the physical demands, the repetitive motion, the exposure to hazards like smoke and arc flash, and focusing the welder on more creative and challenging tasks. And so there's opportunities here, either in one piece or in 1,000 pieces, to do really cool things. But really, there's so much more. And so with 8 years of this going on, there's a lot of advancements in collaborative welding that have been going on. And that may be a little bit hard to see. Sorry about the contrast there. I need to change that slide in the future. But, laser welding is being done in a couple of our partners here in the North America and some in Europe and some in Asia. Spot and stud welding is going on. Metal cutting, you're going to hear about metal cutting today. Thermal spray coating, Cobot portability, the fact you could bring the robot to the work, tending like a resistance welding machine, and then expanding the reach and high volume. And so when I want to focus on the last 2 today, you're going to hear about a couple of these also from Matt. and in other webinars like laser and spot and stud welding we've talked about in a previous webinar as well, if you want to go check out that recording. But high volume production and traditional automation, most folks, when they think of a cobot, they think of high mix, low volume, and they don't think of high volume production. But actually what we're seeing in the market is many people are embracing the cobot for more traditional automation applications and higher volume production applications. So here's a quote from Chris Anderson. He works for Betcher Manufacturing in Mexico. And he said, "I was having an issue getting qualified people that could program, adjust, and develop the setups for new products on our existing traditional automation cells. I was looking for something that was easy to use and easy to teach, something that didn't take a college education or high school education, that somebody could operate it and understand it. For operators to just be able to grab the torch, put it where they want it, and simply say touch up was huge." And that came from a previous webinar. If you want to check it out, I've got the link down there. It was called the Cobot Welder Uncensored. But that quote from Chris was really powerful, why the collaborative robot was so valuable to him. When we look at replacing traditional robots in the fabrication shop, in the fab shop, the traditional robot, a weld cell can take multiple hours or even multiple days from the interviews that I've done to change over and touch up the points. And so a collaborative welding, by using touch to teach programming, empowers the welders to change over a weld cell in hours or even minutes versus hours or days. And that's really powerful, because if you're a fabrication shop, especially if you're a job shop, when you're not running, when you don't have arcs running, when you don't have arc on time, you're not making money, right? And so being able to have changeover, the known planned downtime you have be much shorter, is more money and more opportunity for you to make more parts. And then also, positioning technologies are available to expand the reach and effective working area of the robot. And all of this allows welders to change over the automation versus requiring a robot technician, which is really powerful, why you're seeing this happen. One of the things I do have to point out, I don't know why my picture didn't show up there, but we're going to go with it. Cobot is a robot, and it's something we have to think about. As we add a traditional automation around the Cobot, we do have to do safety assessments, and we have to look if there's curtains or those kinds of things. And then people say to me, well, then why would I use a Cobot? And it's ultimately about the touch to teach and the really simple to use programming interface, the graphical interfaces, and the step-by-step instructions about how to teach a weld that the Cobot brings, that the robot doesn't, that really makes the Cobot interesting in more traditional welding applications. So even if you have to add safety, or you have to add guarding around the other pieces of automation equipment in the cell, the fact that the Cobot can be taught in that simple way by not robot programmers is a huge value for many people, and what we're seeing being done in the marketplace. So when we look at why welding cobots are starting to dominate traditional robots, it's because they improve the value of the automation investment. When you buy that automated cell, that touch to teach accelerates the setup of new parts, it expedites changeovers, and it creates shorter deployment and commissioning timelines. If you think about return on investment, from the moment when you decide you want to buy automation to the time when you actually get the payback at the end, the amount of time to build out all the automation, plan the automation, and find partners and get everything going can take a long time with traditional automation. And typically the Cobot's a little bit shorter to do the deployment and the commissioning part of the project, and that allows you to get going faster. So then when we utilize the existing workforce, not traditional robot techs, that brings a lot of value, right? We have many people that we've had conversations with over the last 2 years with traditional robot cells sitting idle, dusty, because the trained robot tech left or forgot how it works, or it was just too hard, so they decided to weld the parts by hand instead. Cobot welding can typically be learned in hours, not weeks, and that's really valuable for folks. Days, typically. So then we can expand the impact of automation in the shop, right? Then we can create value for more of our production mix. I see a lot of folks even use a Cobot for single piece jobs because the quality is more consistent and higher, especially when you're doing retail displays, you're doing something that's going to be general public facing. You want the quality of the welds to be really nice, right? And then portability is leading to all kinds of new possibilities about bringing the Cobot to the work. So when we're looking at expanding the reach of collaborative welding robots, the first thing that most people think about is get a bigger robot. And, the UR20 is there. The UR10E is by far the most popular welding robot that we sell. And the UR10E reach is 1,300 millimeters. And that's a very powerful robot. When we look at, by expanding to a bigger robot, we get that much more reach, we get that much more working volume, more than 100%, 144% more working volume out of a UR20 versus a UR10E. But even if those aren't really working, right, many people, when they go to traditional automation for welding, they look at external axis or positioners or rails or these kinds of things. And those become part of the automated cell. And so we get the question a lot, can cobots control these? And the answer today is yes, absolutely. Cobots can control these with the Universal Robots Motion Plus platform. Motion Plus is this add-on software. It's an API that allows the UR controller to coordinate robot motion with external servo axes. Again, my picture didn't load. I'm not sure what's going on with my deck, but we're going to keep going. So this API really consists of functions of coordinated motion. It uses EtherCAT for drive communications with the servos, and functional, even more functionality will be added in this space as we go into the future. So Motion Plus enabled solutions from Universal Robots. You can get them from partners, you can get them from integrators, OEMs, and end users can use these to expand the capabilities of their robots through external access control. And this is really enabling more and more traditional robot applications. You're going to see some of those from Matt in a second. So how does Motion Plus work in the most basic way possible? Motion Plus works, the UR controller itself contains the model and the kinematic tree and everything necessary to make the coordinated motion happen between the robot and the external axis. We have an EtherCAT UR-CAP service that does the communication between the servo and the robot, and no external PLC is required to use and utilize Motion Plus, but it is an API that's integrated by other folks. This is a back-end integrated by UR, and then partners like THG integrated into their product. So can I assume this external axis is collaborative? Unfortunately, you cannot assume that an external axis is collaborative. That's not the intent here. The external axis motor systems typically don't sense the presence of obstructions or collisions or pushback from the human operators. So proper safety risk assessments must be made when utilizing external axis, and likely safety systems must be put in place to protect the operator and the robot from the external axis. So when we look at how do you as a user access this and how do you get Motion Plus, ultimately you purchase the Motion Plus enabled solutions from partners like THG Automation. You're going to hear about Matt's solutions next. Or if you're someone who actually makes solutions, maybe you're one of our partners out there in the audience, you could integrate Motion Plus into your own rail or your own axis, and the information's on the UR website. So UR ecosystem partners absolutely make all of this possible. I'm so excited to have Matt here. And with this kind of philosophy that we have at UR, where we're a platform that others can build and make successful organizations on that, we're really committed to your success, and we're committed to their success at helping you have access to automation. And so I'm going to turn it over to Matt. Matt's going to talk about the Cobot welder with synchronous motion. And I'm really grateful he's here. And Jules, if we can share Matt's presentation, that'd be great.
Thanks, Will. I appreciate that. Your presentation was great, and I think it was spot on, explaining the iterations that the platformers went through and how partners have expanded on the capabilities of Universal Robots API, the UR-CAP capabilities, and being able to move into new directions and expand their app store for robots. And I think you said something really great, that cobots are robots. And I think at some point in time, cobot's going to be a less important piece of the description, and more of the main street explanation is what you can do with it and the types of applications that you can apply with it. So yeah, my name is Matt with THG Automation. We are an OEM, an integrator, a partner with Universal Robots. We've been working with Universal Robots for a little over a year now to develop the Motion Plus ecosystem with the robots. So UR has done a great job with developing the back end capabilities of the coordinated motion, and then we've been working with them to help test and build a front end for coordinated motion. So with that said, THG Automation is and has been a really industry leading Cobot integrator. I say integrator loosely because we really like to be a product company, because we know that people want to buy something that out of the box works and it's not a science project. And so when we started THG Automation, that was our focus, is to productize the robotic welding platform or cutting platform as we expand our capabilities, so that customers can think less about how to integrate, be trained, keep the right people in place, and more about using the equipment to get to what they want and to realize their ROI. So we are a product-driven company. We take the Universal Robots, the welding equipment, cutting equipment, and we design the software around that so that the equipment's and the technology stack is less of a conversation with our customers, and what it can do for them is more of a conversation, and the ROI and the ease of use and just making their lives easier, saving the hard work that welders have to go through and the environmental issues, saving them from those harms that they're typically exposed to when they do manual welding. So that's been a dream of ours to be able to do that for quite a while, and starting THG Automation was actually a way of doing that. So, again, we are bringing industrial automation as a product to our customers. So, it's a non-traditional market that we're actually had started marketing to, and knowing from decades of experience what the traditional automation landscape looked like, the difficulties of implementing robotic automation, the challenges with the interfaces, the ROI just didn't fit on the high mix, low volume. Like Will said, our customers are those that don't have those needs, that aren't the traditional automotive customers, or the traditional high volume customers, where it takes big bucks to make big volume. So we were excited with the UR platform to be able to build a product that gave our customers an easy to deploy option, easy to learn option, flexible. You can reuse these robots for anything. You're not stuck with the application it was shipped with. So you got the flexibility, the power of what we offer our customers. And this wouldn't have happened without UR's ecosystem. The power we can offer our customers rivals traditional automation. All the advancements and capabilities that you get from the process and the features about a process, no matter what it is, MIG, TIG, oxyfuel cutting, plasma cutting, and into things that we don't do. It's just a platform that's open to do about whatever you want with it. So we feel like this is the future of robotic automation, and really just blurring the lines between what was traditional automation and what's non-traditional with the Cobot market. We started out with Universal Robots because at the time they were the best, and we still think they're the best. They have the most robust, well-supported, consistent quality product that we've ever seen. I've worked in robotic automation for decades, and I've seen a lot of stuff show up on the floor that was DOA. It was no good, had to be repaired. It failed right before runoffs. It just didn't have that consistency. Universal Robots has been rock solid for us, so we're glad we made that choice. We use Synchronous for the welding equipment. We've had a lot of experience with Synchronous in the past. They make what we think is the best welding equipment you can buy on the planet, and the capabilities are second to none. And we've been excited to work with Synchronous, and the integration between Universal Robots and Synchronous has been really, really good. We're excited for what's coming down the road as well. So We use segment tables for the welding side of things because we think it's again the best thing you can buy. And obviously you have the other industry leading partners with Hypertherm and IHT, which we also integrate. And there's other things we're doing too. We're going to release some IPG laser welding systems here soon as well, and you'll see a little bit coming up here. The portfolio that we have with THG Automation spans quite a bit of processes and capabilities. And I want to get into this a little bit because this kind of spells the overall theme of what you can take and now integrate with external axes and then with Universal Robots Motion Plus, which I think will kind of tie all this together, that there's so much that's coming that traditionally customers couldn't accomplish. Because they couldn't take the advancements of traditional automation, but yet have the ease of use and flexibility of the Cobot. So we've taken from the beginning the MIG applications, and we've started out from the basics, right? The basics of welding carbon steel and stainless, and then going into aluminum, exotic materials. And these are all supported by the Fronius ecosystem, the Fronius power source, and tried and true industry leading capabilities that the Universal Robots platform has allowed us to integrate with this. And we use the UR10, UR20 robots, just about anything with payload high enough to handle the process, the end of arm tooling. We can support that with the robot. We also do TIG. I know Will mentioned that a little bit. TIG welding is not as easy. It's really credit to the welders out there that are good at MIG or TIG welding. But TIG welding is, there's a lot of things happening at once, and it takes somebody with some good knowledge to make it work right. But we have customers, especially in the aerospace environments, that they require it. Food grade, again, you'd have to use TIG in a lot of food grade applications, and we know our customers needed that. So we built a TIG welding solution that's nice, rounded, with just about every capability you can imagine with any traditional type of automation. We do that with our Cobot because, again, UR has the platform that allows us to create the software and the functionality that our customers need. We've got oxy-fuel cutting. We've got customers that are using this for thick materials, beveling. They've had a lot of issues with using track-based solutions where they're trying to cut parts, and they were getting, had a lot of scrap rate, a lot of mistakes. So we generated this Universal Robots-based platform with IHT so that our customers could easily bevel and repeat processes with the oxy-fuel cutting solution that we bought from IHT. And IHT has really done a great job of creating a complete package that's great for gantry-based or for 6-axis robot-based applications. And that then extends to what we do with plasma. Plasma, we've got some really cool stuff coming with that, including the ability to cut corrugated material without programming all the undulations in the material. Of course, being able to do simple shapes just by putting the robot where you want it and then saying what size hole you want to cut or what type of square or rectangle. We've got some really cool functionality that we've been able to do, again, because we've got the platform to do it with. And we're excited to get some of that out as well. As time goes along, the website will be populated with that, and the UR Plus platform that UR has created for us is really awesome too. So you can go on there and also peruse all the 400 and some different applications Universal Robots offers. The last and not least piece of that we offer currently with our welding and cutting solutions is up to 4 axes of linear or rotational axes control. We use the robot controller, Universal Robots programming platform, to control up to 4 axes. It works great. It's Modbus based right now because of consistency with the controller's capabilities. And we've been selling a lot of positioners in the linear and rotational axis types to customers, all over the world. It's been a hot item. We've seen this coming. We've seen the capabilities that customers have been looking for, and this is just the nexus. This is the next thing that needed to come with the Cobot, because the ease of use needed to be expanded out into more traditional automation platforms. And so probably 2 years ago, we came out with this for a customer, and it's exploded from there. And I don't think that half of our customers will be able to use the automation near as much as they can now without the linear and rotational axes capabilities. So headstocks, tail stocks, you can do robots on tracks, you could move parts on tracks if you like, and all that's controlled from the Universal Robots pendant through the standard Universal Robots UR cap. It's awesome, and our customers are really loving it. That said, there's a lot more that we wanted to do with the Cobot, and we were working ourselves to make this happen. Once we found out Universal Robots about a year and a half ago was going to do coordinated motion as well, we partnered up with them, and we've been really excited for this day to come, because I think this is going to explode with knowing all the applications our customers are trying to achieve. So with that said, what is the external axis? How does it add value? So some people that have seen external axes, maybe they've rotated pipe, or they have created some type of flip mechanism to flip a part back and forth. Those are pretty basic. You got an air flip, or you got an electric motor that spins, and you got to do a timer or something like that. Those are the basics ways of doing this. But because we're servo controlled, our customers can take things like large assemblies that you have to reposition for robots to be able to access them. You can rotate pipe while you're welding it. You can do, flips of like ladders. There's so many things that our customers need this for: fuel tanks, large mufflers, you name it. There's so many ways this could be utilized, including building stations out of this. So you could flip to a left station or a right station or a forward station, back station 1, 2. So there's so many ways you can take those 4 axes and implement them in with our system, because of the flexibility of the platform we've worked with. So, let's go back to basics: the 6-axis robot and its limitations, and why the external axes have been such a big win for us in the Universal Robots platform that we've integrated with them with. The 6-axis robot that's just 6 axis, right? So your reach is based on a radius. That radius is both up, down, left, right. So, the robot can reach so far, that's it. You can put an end effector on there to give it a little bit more reach, but then you have to deal with some of the issues where if you rotate the torch backwards in a welding or cutting application, now you've lost distance from the center of the base of the robot. So, these are challenges that you could fix, I guess, if you changed your end effector, or if you, did some type of creative, mechanism on the end of it, or if somebody moves a part and makes it closer to the robot when it's in the process. You could also go with longer reach robots, but now you've got a heavier robot that's more expensive, that's harder to manipulate, and potentially you lose safety because of that reach, the speed that it's moving at that distance, or the payloads that it has. So the external axes has been huge, and this is before coordinated motion has been available. So that's really the basis of why extending coordinated motion with the external axes is going to be huge. So if you're counting these axes, right, one motor on a robot means 1 axis, and the robot typically takes up 6. And in this case, they do, because we're using Universal Robots as the example. But once you get to 6 axes, now you've got another axis that's external. So you got a 7th axis, and a lot of people call it 7th axis, but really you could do a 2nd external axis, and you would call it axis 8. Then you'd have a 3rd external axis, and you could call it axis 9, and you can keep going from there. And coming up with coordinated motion, we'll be able to do 6 extra axes. So you'll be able to count that number up to 12, and you'll be able to group those together. So this really, really makes a huge impact on the capabilities and what we see coming with this type of solution. The current things that we sell right now are servo controlled, not synchronized or coordinated. Like I said, we go up to 4 axes. They're really easy to program. Again, it's the same ecosystem as our welding or our cutting. You just put the external axis UR cap in the robot. It doesn't have to be our system. It could be anybody else's. You buy the software from us, and you use any type of Universal Robots E-Series or the 20 or the 10, UR10 or 20, or sorry, UR20 or 30 robots, and our software plugs right in. And you talk Modbus. We've got some setup stuff for it, and you can use it with other applications. You could use it with gluing. You could use it with, some type of maybe material handling application where you want to slide some pallets back and forth and you want to control it with a servo. All that stuff's totally capable with what we've got, and it doesn't have to be a companion with our welding and cutting, which is the great thing of what we're offering, because this isn't just about us selling what we offer in the welding and cutting, but this is about us allowing customers to use a simple to use robot, easy, flexible, and be able to extend its capabilities past what just the robot itself could do. So this is an important piece of, I think, what Universal Robots has been pushing for, and what we've been pushing for, in order for our customers to have access to the things they've needed and traditional robotics has not given them. So again, it's, adding the reach for applications they couldn't access before. If we go into the rotational side, again, a rotational axis is just, it's a single motor, your 7, 8, 9, 10 motors, which are your axis, 1, 2, or 3, or 4. And you can rotate something from a point to a point with the program knowing where that axis is at, but you don't have that coordination where the robot is able to follow a part. But this is the stuff we sell right now, and it's been a really popular item. These can be used, again, for flipping a station back and forth, or you can do some type of, spin and weld, or you could do cutting where you flip a part to cut one side or the other. It's really kind of up to you what you want to do with it, as long as you're not trying to coordinate the robot with it, with our current applications. And again, you control it in degrees of rotation. If you go to the linear side, it's a little bit different. So the linear axis gives us the ability to move the robot from one spot to one spot with that servo control again. So you'd measure that in millimeters or in inches. You can move the robot between stations. Let's take this example here. You could have 4 tables set up in a grid, and the robot could access 4 tables and call those 4 stations. And we've got customers doing that, and it's worked out wonderfully. So you really take the robot that you wouldn't want to put a bigger robot in, or you couldn't put a bigger robot in, but yet you could access all these stations by just putting a track underneath it and then adding that to the program capabilities. So, doing things like structural beams, trailers, ladders. We've got customers doing roll-off containers for trucks with 6-meter tracks. There is a limit on the length of the track we can implement, but it's getting longer. So there's really some cool stuff out there that we can and cannot share that our customers are using these for. And, augers, centrifuges for for ethanol manufacturing or for creation. And then, just any type of long part where the robot's radius that we talked about earlier really isn't as important as the robot's linear reach. So there's a lot of stuff that these tracks have been great for our customers and allowed them to do stuff they couldn't do before. The synchronized motion with Motion Plus, the synchronized motion really is with the robot and an external axis, or up to many external axes, being coordinated and made possible with Universal Robots Motion Plus application, along with THG Automation's ability to take that and create a nice, friendly user interface for that. So where this sets is, we now can synchronize the robot so that an external axis rotating, the robot knows where that's at. And so they call that synchronized. So the robot and the axes will move at the same time, and they'll achieve their respective points at the same time, making things like you see in this picture, this piece of pipe, totally doable now with Universal Robots platform, where we couldn't do this stuff before. So odd shapes, off-center shapes, oblong, just any type of component that needed to be welded, cut, or glued, or any type of process you want to apply, that can be achieved by simply adding this capability. And this is going to be huge for again, the robot and the options that our customers have. So why coordinated motion with Motion Plus? Well, the tracking of the robot's position, again, when the robot goes to a position and the robot stops the same time as that axis, that's not the end of it. The robot knows where it's at as it's moving. So it's now changing its travel speed. So let's say if you're trying to weld a piece of material and the robot is rotating or moving around that part as that part's rotating, the robot's actually maintaining its travel speed, or its TCP, tool center point speed, as that part rotates, because the Cartesian coordinates that are attached to that axes are rotating with it, and the controller knows it. So it's more of a complex process in the background, but what we do is we make it super simple for the customer to be able to implement it quickly, easily, without having to know all the details about how it works. So now we can start doing things like, in this case, we got some track applications where the customer, there's a point in space that is not moving, but the robot can be moving, and the robot knows where it's at in relationship to a point in space that's not moving. So now you can weld parts, and you can shift, and you can do touch sensing, and you can do seam tracking, and you can do path recording, and all the things you would normally be able to do with a traditional industrial robot, you can now do with this coordinated motion. And the robot knows where it's at, and it knows how fast it's moving in relationship to points in space. So this is going to be huge for the track applications, and you can combine it with rotational axes as well. So again, up to 6 axes can be moving, and you can tie those all together, and the robot controller is tracking all that stuff at once. This bracket in the lower picture, you can go around that square tubing that's chamfered into that flat plate. You can weld that entire part, and it will finish without stopping. So you can get a start and stop on that at the same point, and you don't have to do a flip weld, a flip weld, and flip weld, and then in some cases create leaks if you're welding a pipe, or if you have got another application where it's not advantageous to have those starts and stops in your parts. This will allow you to get away from that. So it's drop centers, again, sky hooks. There's if you know what those are other larger assemblies that are used in large manufacturing capabilities that we'll now be able to have access to and be able to implement and give to our customers. The applications, we're talking about, exhaust components with mufflers and pipes. Those will now be accessible. So if you got off-center components that are rotating and they're getting closer and farther away from the robot knows in space it's drawing a circle, even though that pipe is swinging around as it's being welded. So all that stuff can be tracked now. Augers, like you see in this picture, that stuff is completely doable now with coordinated motion and the Universal Robots platform. So this will be something that's just going to be game changer for our customers, and the ease of use is going to make it where it's accessible for high mix, low volume applications. Continuous cutting on pipe, that'll be accessible now. Welding around odd shaped parts, that'll be accessible. And then just complex geometry and period, even if you're not welding and cutting, you'll have access to that here in the future. So we're really excited for that. So how does this make a difference for our customers? Well, again, they're going to be able to process complex parts they couldn't do before, continuous welds and cuts, and gluing applications where starts and stops are not acceptable, where you have to have hermetic seals and starts and stops create issues, or they create stress points for failure. All those things can be now eliminated with coordinated motion added to the Universal Robots platform. And again, it's not just for welding, but it's for dispensing and grinding, additive manufacturing, and other applications where the Cobot traditionally wouldn't have made sense because they didn't have full control and full positional information from those axes. So what's the future? This is going to allow companies to take advantage of the Cobots in more traditional applications, like Will was talking about, than they ever could before. And it's going to bridge that gap, or maybe blur the line between Cobots and traditional robots. Things that people said, well, you can't do that with a Cobot. You're not going to hear that much anymore. They're not going to have any validity to that. It's going to be a really, really interesting future for the robotics industry in general, because now more people have access to the value that automation brings to in traditional applications, more automotive and aerospace environments, where now the Cobot will be a great fit for this. And I can see this even going further in the future. And then just a little tidbit of what we're going to offer. Eventually, we'll offer a more universal platform so that a customer can implement just about any type of process with our coordinated motion Universal Robots UR cap, And that way they're not stuck buying the process and the equipment together. Or if they have something that they want to implement coordinated motion with, but it doesn't allow them to do it because of who they bought the equipment from, they can easily transition that over. They can control the IO, and we'll allow them to do some of the stuff they couldn't do before with our add-on application to the platform. So this will be really cool for customers that are really kind of stuck in this quandary of, oh, I need this, but I can't do this if I buy that. We'll make that a little bit more universal, if we say that. With that, what challenge are you trying to solve?
Perfect. Thanks, Matt. That's really awesome. I'm very excited. There are a lot of questions behind the scenes and questions in the audience chat. And I think we've got people thinking about what's possible. So Jules has been kind of going through the questions and putting them together. Jules, I'll turn it over to you to kind of lead off the questions from the audience.
Definitely. Thank you, guys. That concludes our main presentation portion. Thank you for sharing your expertise with us. Now it's time to address the questions we received during the presentation. If you haven't submitted a question just yet, you can still do so using the box on the upper right side of your screen, so you can send them in there. The first question that we have is, I need to weld length of 96 inches. Can THG Solutions do that?
Simple answer, yes. We'd have to see your part and more details about it, but seems like we could do that just fine. We've got customers doing 20 feet and 30 feet of component length. So seems like it'd be possible.
Mm-hmm. Sounds good. Another question that came in was, do you use sensors for any welding applications to see where the work pieces are when tight tolerances are needed or the material is thin?
Loaded question. We don't add anything to the robot. Not that you couldn't, but we don't. We have a very, very comprehensive list of capabilities with the MIG welding and some with the TIG. It's limited to that, though. The MIG welding equipment can actually do some things that you couldn't find normally unless you use a camera. So we can search overlaps. We can search joints. Some things we can't find. We probably can't measure tolerance necessarily, but we can do a lot of things that most people haven't seen a Cobot do in the welding applications.
Awesome. Another question, how do you keep and ensure welding paths are precise?
That's a loaded question as well. Precision is relative to what? And that's a question back to you, whoever asked the question. Precision is based on how you're evaluating the robot's start and end points and how you're measuring its process as it's doing it. So, this would be based on measuring what the robot should be doing or evaluating what it should be doing for each application, just deciding what's the best way to execute that application. So I don't think there's any direct answer to that because there's so many different ways that could be approached. But the robots are accurate to like 5/1000ths of an inch of repeatability. So if the part's not in the same spot every time, we can usually find it and then reposition the robot to the part. But if the part's tolerance is off, all we can do is tell you, hey, it's not where it's supposed to be. So it depends on whether the dog wags the tail or the tail wags the dog. I guess that's how I would sum that up.
And you're using feedback from the power source to kind of create a closed loop.
There's no third-party stuff that we use in our traditional applications or our canned applications. It's all feedback from the power sources, which is why we use Synchronous. It's the only ones that do it.
Yeah. And for those who are looking at a camera or looking at a laser line, like one of the great things of the Universal Robots ecosystem is there are many UR Plus partners that have these kinds of tools out there. So there are weld path camera tools and there's laser line tools that are in the UR Plus ecosystem. So THG solves a lot of the solutions using the feedback from the Synchronous power source. But if you don't have a Fronius power source and you need that kind of positioning or feedback, then those tools are utilized by other partners and by many customers. So yeah,
Exactly.
it is a good point. But the
Yeah,
Fronius power source is
a lot of
really
options out there for sure. Yep.
Mm-hmm. Awesome. Another one here. It looks like this person has a UR and turntable. So they're looking to know what they would need to get or buy to implement this on an already existing system.
Yeah. The easiest way is just contact us and we can look at what system you're using. There's most of the E-Series robots we can install our software on. Depends on who sold them the system, what that latitude is. But the easiest way is for us to look at it and then we can just offer them the positioner equipment with the software and they can just add it to what they already have. And it's just a plug-in basically. It's just an add-on to what they have based on their needs and applications.
So you could add the THG if they have access to a pendant. And they're using another welding partner. They could add a THG positioner to that solution. Typically, is what you're saying.
We've had competitor systems where we've added our positioners to it, and you don't get all the functionality, but you do get a good amount of that functionality, including the ability to control the positioner by rotating it to whatever position you want and control the degrees without having to put timers in and stuff. So it's definitely not, low level. It's definitely, a pretty well thought out integration. It's just sometimes mixing our stuff in with other companies' software doesn't work 100%. All the functionality doesn't work 100%.
Mm-hmm. Another one here, can you talk a little bit about the user interface? How does one program as a user?
Yeah, if you've used Universal Robots before, it looks just like Universal Robots ecosystem. You have a node, you click on the node that says, hey, I want to do a position mode, and you put in where you want that positioner to rotate. When you play your program, it rotates there. It just, when it gets to that node in the list, it just rotates to where you tell it to and how fast you tell it to. You can tell it to rotate while you're doing something else, or you can tell it to rotate and not do anything else until it's finished. You can also rotate up to 4 axes at once. So there's really a lot of options there, and it's really easy to use.
Sounds great. This one kind of piggybacks off that one. What level of technical skill is required to operate the Cobot welding system?
I'll split the robot functionality and the welding up into 2 conversations. As far as the robot's concerned, somebody that's got a computer skill to some degree, or somebody that's open-minded to the application, if there's already a preconditioned mindset around it, it could or could not hinder them in being able to be able to use it. But it's pretty simple, and UR and the UR partners offer a lot of training, both on-site and off-site, to where you could learn this pretty quick.
Yeah, I mean, I'd add to that about the robot, Matt. All 3 of my kids, 12, 9, and 6, with just 20 to 30 minutes of education, are able to utilize this thing to have it do things. To do little applications. So,
and online resources are huge. There's so much out there. It really is. It really is a cloud sourced environment when it comes to all the things that you can attain as far as information about how to use the robots, both low level or simple stuff, all the way to developing UR caps just like we do. We weren't given any special treatment when we developed this thing. We started online, we pulled the stuff we needed, and we started writing code, and we were able to do what we can do. And customers don't have to do that. They can just take what we offer or other partners and just plug it in and start working it.
There are so many questions coming in. I can't even keep up with them. And we're kind of getting towards the end, unfortunately. I think maybe we got time for one more, Jules.
Yep. Yeah, sounds good. One more question here. What kind of maintenance and upkeep do Cobots require?
You want to answer that, Will?
Yeah, I think generally speaking, not very much. There's some basic things that you need to do and pay attention to. With our new UR Care program that's released, even taking care of the robot on an annual basis and inspecting it, make sure everything's running well. UR Care kind of takes that out for you. UR will kind of help you work through that. So there's some really not a lot of things are necessary, and if you don't want to own that, UR is going to help you do that.
But ultimately, there's no oil, there's no batteries to change. If you ran the robot for years, I would definitely, check it, right? But I'm sure customers have ran these for years in dirty environments and haven't touched them once, and there just isn't much to do to them. They just work.
Yeah, I mean, we had a customer on the West Coast. They ran it doing a hard-facing application for 3 years, and they thought for sure all the fine particles would end up inside the robot, and they took all the covers off, and there was nothing inside. So they really, it holds up, and it's designed really to be automation for anyone, to be approachable and easy to use, and that goes into even the user experience of the service and support of the robot.
Mm-hmm. All right, well, that's all the time we have for questions. Will, I'll pass it back off to you.
Really appreciate that, Jules. For all those that didn't get their questions answered, and there are so many in the chat and in the Q&A, I really appreciate your engagement. We will try to get back to you via email or via other ways after the webinar. So don't think we didn't see your questions. We just ran out of time. So when you're thinking about next steps, I just want to kind of wrap it up real briefly. We have a welder shortage. I didn't really go into the labor challenges that are out there, but they're big. They're big in every country, not just the US, but they're big in Europe. They're big in South America. It's even a problem in China. I was there a couple weeks ago. So there is a welder shortage around the world, and that's a challenge. And one of the things I want to implore you is, if you think you have to add automation, yeah, definitely. But don't go and swap a welder shortage for a robot tech shortage, right? These skills are in short supply, and if you aren't careful about the automation investment you make, you could really just be taking one labor shortage and swapping it for another. And so collaborative robots really allow you to have your welder run the automation, and that's really powerful. And just as a refresher, welding cobots are dominating traditional robots because they're improving the value of the automation investment. They're utilizing existing workforce and not the traditional robot techs. And cobots are really expanding the impact that automation can have in the fab shop way beyond what a traditional automation investment can do. UR is the definitive market leader for collaborative welding. We're on our 6th generation of cobots, while most are still on their first. We have 8+ years of collaborative welding experience, more than any other robot company. And we have hundreds of great local and global solution partners like THG that are integrating and adding solutions together, and hundreds of years of welding robotics experience in the UR ecosystem. The THG folks are just absolutely loaded with experience and knowledge, and you could see that today in Matt's presentation. And we have thousands of successfully deployed Cobot welders around the world, adding value every day in a fab shop. We have this strong global partner ecosystem. If you're thinking, I would like to be able to do this with welding, if you could get by with the standard solution, there are standard solutions like some of the things you saw in the Cobot cart that Matt presented. But there's also, if you need more customized or specialty situations, there's ways to do integration, like some of the things Matt presented. And UR stands up to the competition. We have a market-leading welding path consistency, and repeatability. It's been widely tested by many customers and other third parties, and we create really consistent part quality. We have this awesome partner ecosystem that combines the free drive touch to teach, and it just makes really great operator engagement and flexibility. I encourage you to get a pendant in your hand and try it out. THG's contact information is there, welding automation for everyone, and I love it. They have an awesome set of videos on YouTube. If you want to see any of the individual features, I saw some questions about multi-pass welding or filling a gap. I mean, go and check out their videos. They've got a really nice library on YouTube. And then really thank you all for attending today. Really appreciate you. There's Matt's LinkedIn and my LinkedIn. And thanks so much for joining us today. If you have any questions, reach out, and we'd love to talk.